Hello, my name is Arya Shadi. I'm one of the developers of SP-Depo wax deposition software. The co-developer is Dr. Ekarit Panachoran Sabat. In SP-Depo, we predict several characteristics of wax deposition, and some of the functionalities are not available in any commercialized software. For example, solid phase composition is predicted by SP-Depo and has been verified by several experimental data, obviously in addition to thickness and solid wax fraction. So here I'm going to go ahead and this is a tutorial to show how to run the program and show some of the main functionalities of our software. So in here, this is the logo of our software, and is equipped with a new thermodynamically coupled wax deposition model. So I'm going to go ahead and try to open an already existing file which I previously saved, so we can save time. And let me open it. So this is the main window of our software. So through these tabs, the input information should be provided. For example, the liquid properties of the existing liquid properties should be provided, including density, viscosity, and as you know, it should be provided through equations because they change by temperature. The same for pipe properties, inlet condition, the entering temperature, and also the velocity. And you provide the surrounding temperature as surrounding information. In this case, since we proved and verified our model using experimental data, which they used pipe-in-pipe countercurrent coolant, and so that's the case it is over here. So I want to talk mainly about the simulation options. So in SP-Depo, we made it possible so users can choose several common wax deposition models. For example, Sing 2000, Lee 2008. For example, crystal aspect ratio formula is provided either by Sing or Lee. And also, based on the model they have chosen, the fitting parameters of both models can be chosen over here. And at the end, Panachoran Sabat 2012 wax deposition model is included, which has two fitting parameters for tuning purposes. One specific thing that I want to mainly talk about is that during my PhD, I have developed a new wax deposition model, okay, that incorporates a thermodynamic tool inside of the wax deposition theory. And in my previous paper, I made an open source wax deposition software which is publicly available, which is called SP-Wax. However, for precipitation curve, it has been common to provide the precipitation curve for by only one equation, the same for dc/dt. This results in major problem because wax cannot be wax consists of several enalkenes that individually participate in the deposition process. So that's why the thermodynamic model should be incorporated during the calculation to calculate the concentration, dc/dt, and also wax molar volume, which we made it possible. So let me choose the new SP-Compo model, okay, that incorporates SP-Wax thermodynamic tool. So in SP-Wax, which is available in Software X journal, the composition of oil is provided, and also some other input information. And after providing all the required inputs, the experimental data can be given, which is about thickness, wax fraction, and solid phase average carbon number. And now that all these experimental information are provided, so user can go ahead and let me create the input file and also search for those tuning parameters, so fitting parameters. So In SP-Depo, we coded a strong optimization tool manually by Levenberg-Marquardt. So after running, it's going to find out what are the fitting parameters are. However, I previously ran this and found out the correct fitting parameters, the best fitting parameters are these two numbers. So that's why, because we don't have much time, I'm gonna perform the calculations. So the calculations are going to be performed for wax deposition modeling, and after running this, all the results are going to be generated and plotted. Okay, so it's going to take maybe 20 seconds. Yeah. So the results are generated, so the user should go to the result visualization and plot the the prediction versus experimental data. So this is the average deposit thickness, and this is the average deposit wax fraction, or FW. Okay. So the best feature that we are most proud of, and it is unprecedented in any commercialized software, cannot be found anywhere else, is the solid phase composition. So solid phase average carbon number, as you can see, is plotted within two limiting range that have been explained in my dissertation, and also the deposit temperatures. As you can see, experimental data are quite perfectly matched with our prediction, and also user can plot the average the carbon number distribution of the solid phase for different temperatures as interface temperature, deposit temperature, and wall temperature. Okay, so aside from those, the temperature distribution, as well in radial direction, in axial direction, all these required inputs, wall temperature are provided, and also here is the temperature profile within the pipe that we made it possible. So we used Python script for data visualization because it has such good quality, and also some of other information, so solid wax fraction versus time. So all of the required inputs to make sure that the model has been run properly have been included in our software. So, and also you can check the thermodynamic model to see if it has been run correctly, and you can see here it has. So, and also in my dissertation, I verified our model through more than 12 flow loop experiment data from more than 12 flow loop experiments. And also we made an upscaled sensitivity case analysis, and we showed that SP-Depo works in that condition as well. So I hope that this tutorial was helpful, and this software is in for commercialization, and please let me know if you're interested, and we can talk more in depth. And I have included my email, so I'm more than happy to discuss more about our software. And thank you so much, and have a good day.